famous LeetCode problem, the two-sum problem. So given an array of integers, you need to find if there are two numbers which they add up to the target. So you'll be provided with a nums array and a target, and you need to find if there are two numbers in that array that adds up to the target. So one of the brute force approach would be to loop through. So the brute force approach would be to loop through the array, and then for each element you need to find if check if there is an element that that adds up to the target. So basically you will have to run two loops to find if there is any element that satisfies this target condition. So basically two elements needs to add up to the target, and so you need to check for each element, and then you have to do this for loop two times. So this will result in a so this is the time complexity will be like O of n square. This is because and this will lead to a TLE, time limit exceeded error. This is because the array length given is 10 to the power 4, which is so for each iteration, so for that means in the worst case scenario you'll have 10 to the power 4 iterations, and there are two for loops. So that means 10 to the power 8 iterations can happen in this with this approach, and that could lead to a time limit exceed error. So so the brute force approach is not feasible here. So the faster approach is to use a hash map. So hash map, what we do is we check for the existence of the complement of the element in the hash map. So complement means the complement is actually the target minus the element. So we just need to find if this element complement exists in a hash map or not, and the type complexity for this approach is order of n is the time complexity. The space complexity will be order of n because you are creating a new hash map. So so that is the time complexity and space complexity. Also the fetch the get method for a hash map is order of 1, so that is pretty fast. So overall this is an accepted solution. So let's try to code this up. So what we do is we loop through the array first. So okay, now let's find the complement. Complement is basically the difference between the target and the current element. Now if okay, and before that we'll have to initialize a map. So like map. So this initialize a hash map. So now inside, now we need to check if map dot has, I think it's just the syntax. If you have this complement, then you need to do a bunch of stuff here, else to do some stuff here in the else case also. So let's go through this logic first. So if the map has the complement, then that means there is a pair that exists that satisfies the target. So so we just need to return an array. So the problem statements ask us to return the indices of the of those two numbers in an array format. So the order does not matter. So let's return map dot get. So before going into this, let me just give you a quick idea of how we're going to store this elements. So inside the hash map, we're going to store this as the value of the element, value of the array, value of the element, and then it will be like an index associated to the element. So it's value and then the index. So here, if the map has this complement element existing in the map, then you return the index. So in order to get the index, you have to get it from the maps. Map.get complement, and then the next one is the ith index. So this is what you have to return back if there is a complement existing. If it doesn't exist, then you just set it in the map. So it will be nums high, high. Now let's take a look at this. So this is order of n complexity. Then this is order of 1 complexity. This condition also order of 1 complexity. This one also order of 1 complexity. So if nothing satisfies, then I guess we can go to null. Okay, so overall the type complexity will be order of n, and the space complexity will be order of n. And let's try to submit this. Okay, perfect. So that is the solution for two-sum array. Thank you. Two-sum problem. Thank you.